divide the motion broadly, then it can be divided into two parts: translational motion and rotational motion. Meaning of translational motion is movement of a rigid body or a particle in a straight line, or if we go into detail, then the movement of the particle is parallel to its own path. Means, suppose this is moving like this, okay? So this is the pure translational motion. And the next one is the rotational motion. The specialty in the rotational motion is particle or rigid body or object is to move about a fixed point. That is, we can say that each of the particle of the object have a constant distance from the axis or from given point. Axis is formed by the locus of the center of the circles of different points. For example, suppose we take this is the axis and this is made of so many particles here. Now suppose we concentrate at individual particles. So this particle is making here R1 radius, another particle which will be larger R2 or R3, all are moving in a given circular path, and this is the center of individual particles. If we connect all the points of the center of the individual particle circle, then this will be the axis, and obviously this is the locus of the center of the circles, all particles. So this is the case of rotation. That is a very special thing of the motion, when at any moment the distance will be always constant. This is the case of rigid body. So similarly, as we done in case of translational motion, kinematics means motion related to the movement of the particle in axial direction or in any other different direction. For example, we have done I, J, K, etc. 3-dimensional motion. In that case, here also we will consider the same comparison for rotational motion also. That is, the same topic, kinetic of rotational motion will also exist here. In this case, we will consider the motion of the particle. Then everything will come the same, like speed, here it will turn as angular speed, linear speed, turn as angular speed, linear acceleration, angular acceleration, and all the equations will exist in the same way, linear momentum and the angular momentum, etc. So we will compare one by one each of the points. Okay? So let us take one of the particle from here and then we write the related terms. So let us circle it here. This is the particle, and from one of the particles is here, and now this is the theta. Suppose this particle moved from here to here, okay, in time t. The linear distance covered by the particle is this s, and suppose this is the circular, obviously, so radius is r. So if we consider the linear distance s, so linear speed we can say s upon t. So linear speed u is equal to s upon t. This is the case of linear speed here, that is distance upon time u. Now at the same time, particle is covering angle in the same given time. In the same given time, particle is covering angle also. Let this angle in the same time is t. So there the term linear speed is changed into angular speed. That is angle covered per second, and that is denoted by omega is equal to theta by t. Okay. Now the other thing, angular speed, average angular speed, linear speed like that, we can calculate here also. So average angular speed means omega is equal to delta omega by delta t. That is, we can write here omega 2 minus omega 1 by t. This is the average angular speed. Now next is average speed, then instantaneous angular speed. So instantaneous angular speed is denoted as omega is equal to d omega by d. So this is the angular instantaneous at any instant. That is, this term can be changed into instantaneous angular speed where delta t tends to 0. So you can write here delta omega upon delta t, right here limit delta t tends to 0. So when delta t tends to 0, like that average speed can change into instantaneous angular speed. Similarly, average angular acceleration. So in the same way we can calculate the other kinematic equations also. What is that kinematic equations? There are, for example, theta is equal to how much? Omega naught t plus r alpha t square omega naught alpha t square omega naught square is equal to omega plus 2 alpha theta. Now in this case, omega naught is the initial angular speed. So here also we can take omega naught square plus 2 alpha theta. So in this case, omega is equal to, now what is the relation between theta and linear speed and angular speed? So linear speed, you can write here v is equal to theta is equal to how much? S upon r. So if you write here theta is equal to S upon r. So S is equal to how much? R theta. Now differentiating both sides. So what will be given? ds by dt is equal to r d theta by dt. In this case, delta omega by average angular speed is how much? Delta omega by, this is average angular speed. So here we have to take the limit. This is average speed, and here we can write delta theta by delta t. This is theta 2 minus theta 1 by 2. So average angular speed is delta theta by delta t, and instantaneous is this is also. So this will be d theta by, and average angular acceleration is what? Similarly calculate here. Average angular acceleration is alpha is equal to how much? Delta omega by delta t, and instantaneous angular acceleration is d omega by d. Now you see here you can write ds by dt is equal to how much? R into omega. ठीक है ना? So V is equal to omega r. This is the relation between linear speed and angular speed. Now if we consider the vector form, this is the scalar form of the equation. So vector form if we consider, then we can write here V is equal to omega cross r. Now to get the total acceleration of the particle during rotation, we have to differentiate V with respect to t. Okay? So dv by dt is equal to Here both are valuable, omega and r both. So you have to represent with time, with respect to time, by the method you will use. So first of all, you write here omega cross dr by dt plus d omega by dt into r. So what you get in here, this is the A total acceleration on the particle where it is having rotation. So total acceleration, that is the acceleration of the particle where it is having certain rotation. In that case, the net acceleration we are going to calculate. Not only one acceleration, what is the net acceleration and what are the component of that net acceleration in the motion. So let us see omega cross r. Here by dt is what? Speed, linear speed. So you can write here A is equal to omega cross b and d omega by dt is the angular acceleration. So you can write here is alpha r. So what is find this omega? Omega you can write how much? V upon r. So if we take the magnitude of the two, so we can write here A is equal to V square by r plus alpha into r is the tangential acceleration. Alpha into r is the tangential acceleration. So the particle has two kinds of acceleration. One is centripetal acceleration, another is tangential acceleration. So you can write here A is equal to AT plus AR. So resultant acceleration at any place, these two accelerations are perpendicular to each other. For example, at this point if you come here, so in that case radial acceleration is air, tangential acceleration is AT. So this particle has two accelerations and both are perpendicular to each other. So obviously there must be a resultant acceleration. So let that resultant acceleration is A and A is equal to under root A square AR square plus AT square. Now we solve a question. Suppose just rotating certain angular speed. Okay. Now the angular speed omega is equal to, or just start from the rest, and angular acceleration alpha is given to you. It is 2 radian per second square. So alpha is given to you how much? 2 radian per second square. So this table starts to rotate with acceleration 2 radian per second square. Now suppose a coin is taken from this table. Okay. So what is the acceleration on the particle after 5 seconds? This you have to calculate. What is the acceleration of the particle after 5 seconds? As you calculate. What is the acceleration of this particle after 5 seconds? This point, friction between the table and the point is sufficient to not slip. Means it is not going to slip. It is also revolving with the same angular speed of the table. So, what is the question? What is the acceleration of this particle after 5 seconds? Alpha is given to you 2 radian per second square.